Hello, and thank you for listening this afternoon. In the morning and also after lunch session, we often heard about the RTEMS qualification. And today I want to talk about the improvements of the RTEMS SMP qualification package as it is available right now. So what will be the content of my presentation? I will update you or remind you about the goals of the current QDP creation. I will give you a brief update on ongoing activities. I will show you 3 possible ways to come to a modified or customized qualification. We'll also point out our embedded brains qualification efforts. And then at the end, I want to emphasize some RTEMS community aspects which should not be ignored. So the current qualification of RTEMS SMP, which is available since last year, was to provide an ECSS Cut C pre-qualified RTEMS as an open source RTOS for the space community. This has happened before, but actually we got the additional goals to allow requalification when patches, changes, improvements come up for the RTOS, and this implied to get an automatic testing approach. The scope was limited to the most important hardware platform like GR712 and GR740, and to the so-called RTEMS space profile. Please keep that in mind. This is a subset of the RTEMS functionality that is available in the open source domain. The status is obviously that their pre-qualification has been finished. The results are available at the ESA website. How about the hardware scope? You see the green area in the GR740 structural diagram. These are the hardware parts that are more or less supported by the existing qualification. But on the right side, the various communication interfaces are not part of the QDP. So please be aware of that. This doesn't mean they can't be qualified, but they are not in the standard package that can be downloaded. And if we look at the software, at the RTEMS scope, operating system scope, once again, the SMP executive definitely has been qualified. The classic API, most of it has been qualified. And the Spark architecture support, including some drivers, has been part of the qualification. But there are still some areas which lack qualification, like POSIX API, most of the NewLib used for C programming, OpenMP, file systems, networking support, CAN support, and something that has also very often been asked for, NASA CFS. So still a lot to do for us. It's not so bad. So what are the ongoing activities? Currently, critical software is busy doing an independent software verification to lever the existing QDP to ECSS category B. And I think there is also some architecture work involved with that. So I'm quite curious on the outcome of that and when the results of that activity will be available. The previous QDP development focused on SMP because this is a vital feature for many products, but as a side effect, we saw that uniprocessor support has not been covered by full code coverage testing. So there's a planned activity, hopefully coming in the near future, that will adjust the QDP to also provide proper uniprocessor full code coverage, and, very important, to update to the latest RTEMS mainline and to also cover some bug fixes in GCC and the toolset. So this is where we are quite confident that the efforts for the initial QDP can be reused for future work. And there are some topics which are open, like improving the document generation and handling, and support for other architectures like RISC-V, for other SOCs like NOL5, GR765, GR716, UT700, and so on. And also to extend the functionality, to extend the covered functionality of the pre-qualification. For example, for communication interfaces. So, in the morning we've seen some projects who already use the ready-to-use QDP. It's fine, and it's nice to see that it's productive. But we have seen many requests from various parties to extend the qualification, to move it to a different architecture or whatever. And we see three ways to come to a future modified, adapted qualification. The first one is the way we are used to come to future functionality or future qualification. It's an ESA initiative, which is often started when there are general needs to get a certain work package done and provided to the space community. And it definitely needs a statement of work to precisely define what should be the result of that initiative. The big benefit for us all is that the results are more or less based on an open source license, so there are no license fee to pay. It's free to use in the European space community. And the ESA is aware, we are quite happy about that, the ESA is aware that the results should be synchronized with the RTEMS community, because only then they can be maintained. I will come to that later. From my point of view, from my personal point of view, the disadvantage of that approach is that the time to availability is rather long. You need a definition phase, you need the tendering process, you need a contract, and then the actual work has to get done, and the results are to be delivered. This is, I think, this is the way the ESA must work with the political and general interaction between various authorities. Another approach would be the do-it-yourself way. This is much easier to start, I think, because actually if in your project you need an extended QDP, you definitely can define the requirements the way they fit to your project. So scope and definition is rather easy to define. We don't have to talk about license, because if you are developing it on your own, then, well, you can use it on your own and you have no further severe obligations. If we look at the cost of usage, it really depends on the skill of your people doing the qualification, because at least for the first works in that area, there is a steep learning curve to be passed. Once again, let's look at the time to availability. It's really individual. It depends on the people you can assign to that project, and definitely, in the end, the results must be accepted by the corresponding ESA authorities. The third way, and that's one thing where we are focusing for the future, is to provide commercial support for creating QDPs based on the same technology but improved. We will see that later. And once again, we have started that with various companies. The project requirements really fit to what you need. The downside of it is the QDP will only be available with a commercial license, just to fulfill also our commercial requirements. And this also defines the cost model. But we are focusing on putting any code change to RTEMS back to the RTEMS community, quite an important point. And our goal is to guarantee a short time to availability so that the qualification will be ready according to your project needs. So what's part of our qualification efforts? It's moving qualification to various architectures, SOCs, modules, and onboard computers, so that there can be ready-to-run packages of onboard computer hardware and the qualified operating system. To extend the software scope to POSIX, OpenMP, various communication interfaces, NASA CFS, and also to provide qualification support for application software. In the big table, I mentioned the RTEMS community code should be pushed there. Actually, what is it? For many people, it's just a hidden instance somewhere behind the curtain, which makes RTEMS code downloadable, but actually how it's working and how it's not working, let's have a look at that. So, who is part of that RTEMS community? There is various company staff, like OAR in the US, ourselves in Germany, and for example, Geisler, which are very active for many years now. There is university staff out of various interests, some freelancers, some interested individuals, but all in all, the core team is approximately 10 to 20 people, changing from year to year. So it's a rather small group maintaining RTEMS and keeping it available. So the responsibility of the community is to port RTEMS to new hardware, to enhance it, to add new subsystems when it's required and convenient, to do some sort of code steering, what should be done and what should not be done with the community code, to keep it functional after tool updates. When a major GCC update comes in, there's always work to be done. New warnings come up, must be checked in the code, and the code must be adapted to take care of them, and whatever. And most important, to keep RTEMS ready for the future, because, well, it's almost 30 years old now. It's still working, it's growing, and it's much more than a collection of patches and code changes. If this steering responsibility is quite important to ensure that RTEMS not only has a past, but also has a future. When some inputs come from the users community, patches, changes, improvements, then the core team of the community reviews these patches, checks whether they fit the coding style, the way variables are named, the way it integrates into the existing code. The community gives feedback how these patches could be improved and where they should be integrated. And last but not least, the infrastructure also must be maintained. Web server, file server, Git server, bug tracking, build servers, test targets. This is all stuff that needs some financing, and part of our income actually goes into that area. And I just want to make you all aware that this community is not only doing things in their private time, but they are really trying to work professionally, and they need some sort of budget. So if you adapt RTEMS to your hardware, if you improve RTEMS in certain aspects, why should you contribute your code? First of all, it's a burden. And if you have the code privately, it's okay for your project. But the benefits of contributing is the code matures faster. There are other users who are using your code. They are testing it in different environments and out of different views, and they are improving it for you, for all. On the other hand, the code is maintained and will be reusable with a future RTEMS version. So if in your next project, 5 years in the future, you want to use the same functionality, it will be there, even with a newer RTEMS version. And finally, it's a question of fair use. It's the give and take, but that's obvious, I think. How can you contribute to RTEMS? Let's concentrate on the red box at the bottom. The perfect way not to get the contribution into RTEMS is to donate 10,000 lines of code without any preparation. Wow, here it is. I send you a present, Christmas present, make whatever you want with it. Most of the times, it will simply be dropped because it's too much work to integrate, too much work to create even a feedback to you. So this way will not work. Therefore, this happens very often when you schedule code contribution at the end of your project. So you already have collected 10,000 lines of code. And so that's really not the way that should be done. Successful contributions will be achieved when you discuss your plans with the community early, possibly even at the beginning of your project. Read and observe the RTEMS coding style before creating the code, because it's really unnerving to move brackets around in your code just because you have chosen the wrong style right at the beginning of your coding. And start slowly. Commit small initial patches. 3 lines are already a very good start to give a minimum improvement to RTEMS. Learn based on the feedback that you get and build up your reputation. And then you can be sure that even bigger patches will be accepted in the future and will live on in the community RTEMS repo. Once again, RTEMS is quite popular in the European space community because it has a long life, because it's available for free, and it doesn't depend on the plans of individual companies or whatever. So one part of the long life of RTEMS one part even for the qualification efforts that they are living on now is that the RTEMS community takes care of the code and is proud seeing the operating system to prosper, to grow, but it also is a hard burden to take care of the code. Okay, these are the most important points I wanted to present you today. So, any questions now?